In this video, we'll look at 6 past paper questions that involve changing the subject of the formula. These are questions that students have answered on the Dr. Frost Maths website and have got the wrong answer. So we'll look at the correct methods and possibly see where the student may have actually made a mistake. So in this question, we have the formula m equals p squared plus x. We are trying to isolate x. And all we need to do here is to actually subtract the p squared term. By subtracting that from both sides, we will have x left on its own. So if I subtract p squared from the left-hand side and do the same on the right-hand side, the left becomes m minus p squared and the right becomes x, and we have already then isolated x, so that is the end of the question. The student here has performed a square root of negative p. Clearly they've looked at the p squared and gone, I need to square root, but it's completely unnecessary. If you look at this question and just go, okay, what I have is one term equals to another term plus the x, then isolating that, just take away this term, this entire thing here. In this example, the student has come up with the answer of 3 as if they are trying to solve the equation. It says make t the subject of the formula, so there's no answer here in terms of t equals a number, it'll be t equals an expression. So looking at the formula, we have p equals the root of a minus t over 2. The initial thing you should note is there's a square root and it encloses everything on the right hand side, including the subject that we want to get, t. So we need to remove the square root. You remove the square root by squaring both sides. So that would give us p squared on the left-hand side, and then the right-hand side becomes a plus t over 2. So that already looks a lot easier to work with. Now the next thing, the t term here is added to a. So treat this term as this is one complete thing, and just subtract the a to isolate the term which involves t. So I will take a from both sides, so I get p squared minus a, and that will equal t over 2. Now I look at it again and I go, well, my t is now the numerator in a fraction. It's being divided by 2. The opposite of dividing by 2 is multiplying by 2. So if I multiply the right-hand side by 2, I just get t. And then I must multiply the left-hand side, the whole of the left-hand side. So it's going to be 2, and then in brackets p squared minus a. Not sure why I put squared there. P squared minus a. And the important thing to note here is put the p squared minus 8 inside a bracket because it's an entire thing. You treat it as one thing and you're multiplying it by 2. In this question, we're trying to isolate the term t. Unfortunately, t appears twice in a fraction as part of the numerator and as part of the denominator. If you look at the student answer, all they've done is substituted t for m. They've swapped them around. You cannot do that. That does not make logical mathematical sense. So the fraction is the difficult thing here. So let's get rid of that by multiplying both sides by the denominator, by t minus 3. By doing that, on the left-hand side, we get m t minus 3 equals t plus 1. Now the bracket on the left-hand side, I will need to expand so I can pull the t term outside. So that's going to give me, multiplying that out, it's going to be mt minus 3m equals t plus 1. Now the next thing to do will be to move the t terms to the left-hand side and the non-t terms to the right-hand side. I'll do it in 2 steps. The first step will be to subtract t from both sides. So I'm going to get mt minus 3m minus t equals 1. And then I'm going to add 3m to both sides. That will eliminate this minus 3m here. So I'm going to get mt minus t equals 1 plus 3m. Now remember, I'm trying to isolate t. I have 2 terms involving t on the left-hand side, so I can factorize, and that is equal to t brackets m minus 1 equals 1 plus 3m. And finally, you should be able to see now that I can isolate t by dividing by m minus 1. So t equals 1 plus 3m divided by m minus 1. Just compare that answer here to the correct answer listed in the mark scheme. It might look a little bit different. All they've done is they've got 3m plus 1, and I've got 1 plus 3m. These two expressions are identical, so my answers are identical, and that will be fully acceptable by an examiner. One final thing to note with this question is that it's worth 4 marks. So clearly, if it's worth 4 marks, there will be several steps involved. So again, with the student just replacing the m with the t, that's too easy. That's too small a bit of work to get 4 marks. So that should be a little warning flag for you. Look at the number of marks. If there's a lot of marks, there will be multiple steps. This question also involves a fraction with the term we want to isolate involved in the numerator and the denominator. So the pattern will be exactly the same as the previous question. I'm going to multiply through by the denominator first. So what we're going to get is 4 plus t multiplied by p equals 3 minus 2t. As before, we need to expand the bracket because that will pull the term we want outside of the bracket. So here we're going to get 4p plus pt equals 3 minus 2t. I want my t terms to be on the left, so I'm going to add 2t to both sides. So 4p plus pt plus 2t equals 3. And then I'll subtract my 4p from both sides because there's no t involved in that particular term. So I've got pt plus 2t equals 3 minus 4p. On the left-hand side now, I have two terms which both have a t in them, so I can factorize. So t bracket p plus 2 equals 3 minus 4p. And then finally, I can isolate t by dividing by p plus 2. So I get 3 minus 4p over p plus 2. With this question, we have an expression and we're trying to isolate x. X appears as the in the numerator and as the denominator of the fraction. If we just pause and have a look at the answer the student gave, they gave the answer of x equals 2. Clearly that's not making x the subject of anything. That's solving, so that clearly would be the wrong answer. And we're looking at the mark scheme. It's 4 marks, so there will be several steps we will need to go through to solve this. So, as we generally do, if there's a fraction, we don't like it, so let's try and get rid of it by multiplying both sides by the denominator. Multiply both sides by x, we're going to get xp on the left-hand side equals 100 y minus x. Now, our term we want is inside the bracket on the right, so let's expand that. That way we can actually release it and work with it. So, what I've got here, I've got xp equals 100y minus 100x. Now I can add 100x to both sides. And what I get then is all my x terms together on one side, and then I can factorize. So x p plus 100 equals 100y. And hopefully you can see now that to isolate x, I just divide by p plus 100. So 100y over p plus 100. Finally, in this question, we are trying to isolate x, and x appears on both sides of the equation. I also have a bracket here. So I'm looking at this thinking, okay, I want to eventually get all the x's to one side, but I can't do that until I've expanded my bracket to pull the x term outside of the bracket. So I'm going to expand the left-hand side first. So the left-hand side will become 6x plus 6y. The right-hand side stays the same, 8x minus 5. That frees the x term on the left. Now, I want the x terms to be on one side and the other terms to be on the other side. Normally, I would try and move from the right-hand side to the left, but if I take away 8x from here, I'm going to get negative 8x here, sorry, negative 2x here, and I don't really want to have negatives if I can help it. So what I'm going to do is I'm going to subtract 6x from both sides, and then you'll see I'll end up with a positive value on the right-hand side. So subtracting 6x from the left, I just end up with 6y. And on the right, I've got 8x minus 5 minus 6x, which hopefully you can see simplifies to make 2x minus 5. Now I have only one term involving x. I'm going to add 5 to both sides. So I get 6y plus 5 equals 2x. And now all I need to do is actually divide by the 2. The right-hand side becomes x, and the left-hand side becomes 6y plus 5 divided by 2. If we look at the answer the student gave, quite possibly they were on the way to the right answer, but for some reason they ended up with y instead of 6y. They lost the 6 somewhere in their workings. Always check, once you've done this, have you done enough work to get 3 marks? Well, clearly we've got multiple stages here, so that's good. And then just checking through, what did I do? I subtracted 6x on both sides, and I tidied it up. I then added 5 to both sides, then I divided by 2. 3 steps, 3 marks. Happy with the answer.